So good morning.
Good morning.
Good. Now today we are on with our revision from where we stopped last time. We are having a revision on the three-dimensional figure and the figure which you are seeing here. So the question reads, let's have one of you reading the question.
The figure below is made up by EF, EH, EKR, in which EF equals 30 centimeters, FG is equals to 9 centimeters, and GM is equals to 30 centimeters. N is the midpoint of LM. Calculate to collect four significant figures, the length, the height.
So the figure that has been read is what you are seeing here. We are having the length EF, which is measuring 40 centimeters, FG, which is 9 centimeters, and the GM, which is 30 centimeters. N is the midpoint of the line LM. When we say N is the midpoint, it means it divides the line LM into two equal parts. And we know the length FG is equal to the length LM, that is by translation. So if we attempt to translate this line FG, it will fit into LM. And we did skew lines. From the skew lines, we said the translation of lines, if we attempt to translate this line, we move it, it will just fit into that. So if we are told that this is 9 centimeters, then it means LN is 4.5 centimeters, which is half of that. And this one, it applies to all questions, all dimensions. FG, it also fits into EH. You also have EF, it fits into what? It can fit into HG. And this one can also fit into KL, which also fits into JM. So that is all about translations. Then you are given a general instruction there, calculate to four significant figures. You are given the first one, you are to find the length GL. From that one, the instruction you are given, it is to write correct to four significant figures. And this does not apply only to the first question, but it applies to all the questions which you are given there. That is for part A, part B, part C, and part D and F. So it means all the answers which you are going to get in that question, you must write them into what? To four significant figures, correct to four significant figures. So let's start with the first one. It is to find the length GL. Where is our G? So this way we have G, and this way we have L. So we are to get this length here. How can we get that length? We simply extract that out. If we tend to extract that, we'll be having a figure of this kind. So we have this here, we have our L, we have our G, we have our F. We know F at this point is a right angle. So this is a right angle. And we know the length LF. What is the length LF? So we translate GM, it is same as LF, which is what? It is 30 centimeters. Then we have FG. What is the part of FG? It is 9 centimeters. Then for this one now, to get LG, which concept do you use in getting LG? So we use the Pythagoras theorem rule. So if we use Pythagoras theorem rule, working that out, it gives you what? So we can say that LG squared is equals to what? You can say it is 30 squared plus 9 squared. When you want to get your LG, it will be the square root of 30 squared plus 9 squared, which is same as getting the square root of square root of what? 981. Because if you square this and this one, it's the same 900 plus 81, which gives us the square root of 981. So if you get the square root of that, it gives you what?
31.32.
It is 31.32. Initially, can you read the answer which you are getting, the whole of it? It is at 1.3209. But answering to the instructions given, it is right to 4 single figures, so it means we need to have only 4 digits. So we count 1, 2, 3, 4, which is going to give us that 1.32. What is the units? It's in terms of centimeters. So that is answering the first question. Someone to read the second question.
The length of
The length of? So we have to get the length of Fj. So length of Fj. Fj. So we have our F here, we have our J there. So it means we can just draw this line from that point to where we have our F, and from J you also draw a perpendicular to the surface of the plane EFGH, which is going to meet what? H. And then you join from H to what? To F. And for that, you will just have this kind of figure, which is coming out. We have this is our J, we have this is our F, and we have this is our H. What is the value of JH? It is 30. We translate this and it fits here, so we'll have this as 30 centimeters. What upon HF? HF is the diagonal of the plane. It is the diagonal of this. So if we have this as our E, we have this is F, we have this is G, we have this is H. And EF is what? It is 40 centimeters. FG, it is 9 centimeters. So from the properties of a rectangle, opposite sides are equal. This is also 40 centimeters. This one will be 9 centimeters. But our interest is to find the length HF. HF. So it is diagonal. And if we tend to use this one, then we'll be having a figure of this kind. We have this our E, we have this our H, we have this our F. So this one, it is 40 centimeters, this is 9 centimeters. Using Pythagoras theorem rule, you can get HF, where we say HF is equals to the square root of 40 squared plus 9 squared, which is same as saying the square root of 1,600 plus 81, which is same as saying the square root of 1,681. If you get the square root of that, it gets what? 41 centimeters. So this is 41 centimeters. We come and place it here now. This is 41 centimeters. But the question which you are supposed to answer, it is to find the length Fj. So we have these two dimensions. We still use the Pythagoras theorem rule, which will be saying JF all Fj is equals to the square root of 41 squared plus 31 plus 30 squared, sorry. So this one it gives what? What is 41 squared? 41 squared is what? 1,681. 81 plus 30 squared is 900. So if you add the two, it gives you what? It gives what? gives one? 2,581. Now, get the square root of that. Gives you 50.80. That is writing to four significant figures. So, we have answered our question. Someone to read part C.
The angle between EM and the plane EFGH.
So you are going to find the angle between EM and the plane EFGH. So we are to find the angle between a line and a plane. Is there any question at that point? Any question? Now, the angle between a line EM and the plane EFGH. How do you get the angle between a line and a plane? So, when we want to get the angle between a line and a plane, we simply need to have a line which acts as a projection on the same plane. So for this one, if we have EM, you just draw the line, that line EM. Then from M, drop a perpendicular that will be meeting this plane EFGH at a point. So if we are at M, we drop a perpendicular, it is going to meet what? G. So we'll be adding, if we drop that, it will be meeting G somewhere. And also from E, we tend to draw a straight line to where we drop our perpendicular, so the two are going to meet at point G. So you have to find the angle between EM and the plane. So this is the angle. If we are having this as the surface, then we try to put a line there, so it means we are getting the angle between this line and its surface, and that is the same as the angle between the line EM and the angle what? And the line EG. So which dimension do we know? 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 We know GM. GM, which is 30 centimeters. Another? 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 E. EG. What is EG?
41.
EG is?
41.
Have we done that calculation?
Yes.
What is our EG? This one. Are they the same? If you tend to get this, are they the same?
Yes.
So if they are the same, we know EG, which is 41 centimeters. So now to get this angle theta here, we use the trigonometric ratio, that is SOHCAHTOA. Under the SOHCAHTOA, we have the opposite, we also have the adjacent. So which trigonometric ratio do we use? We use what? So we say tan theta is equals to opposite over adjacent, which is same as saying tan theta is equals to the opposite is 30 divided by the adjacent, which is 41. Therefore we say that theta is equal to the tan inverse of 30 out of 41. Therefore theta, it will be what? Now take first 30 divided by 41. 30 divided by 41, it gives what? That one, it gives one?
0.7.
Now give the tan inverse of that. 36.19 degrees. That is the value of theta. Sorry? Sorry? Now, Let's move to part E. Someone to read part E. So the angle between
The plane
The angle between the planes EFGH and ENH.
so this what we did is now part B. It is the angle between the plane E F G H and E N H. So we are having two planes. How do you get the angle between a plane and a plane? How do we find the angle between a plane and a plane? The angle between a plane and a plane? So to find the angle between two planes, it means getting the angle that is dividing, or you get the lines, that is the line of symmetry between the two planes. So we have the plane E, F, G, H. So if we tend to look at our figure, we have the plane E, F, G, H. And we also have the plane E, F, E, E, N, H. Where is our H? H. This one. So we have the plane that is joining E, N, H. A plane that is moving will be having something which is like this. It's moving like that. Where this is our N, this is our H, this is our E. And we have a surface, the surface plane, which is also moving, which is making the base, which looks like a triangle kind of. So we are having the two planes which are joining. So for us to get the angle between the two planes, we draw the line of symmetry of the first plane, which will be passing to this point. It meets HE at that point. So we draw from there to meet the midpoint of that. If we are drawing the line of symmetry, we say the line of symmetry is a line that divides a plane or an object into two equal parts. So if we tend to draw a line from the midpoint of this one to the midpoint of this one, let's call this Q. If we have that as our Q, we'll be having a line that is moving like this. We have this our N, we have Q. Q is the midpoint of this one. Then now from N, drop another line to meet the surface or to meet the plane E, F, G, H at a line L. And then we join like that. So we having the angle we are supposed to find is this angle. We join from the plane, from this plane, from that plane E, N, H. We drop a perpendicular. Not really a perpendicular, but a line of symmetry that is dividing. You know that is, it looks like a triangle. The base it will be looking like a triangle. So we'll be having, this is our N, this is our H, this is our E. So we divide it into two equal parts. And we call this point as Q. So that is what we have drawn there, E, Q. Going to the other plane. The other plane is E, F, G, H. We also divide it. You see the two planes, they intersect, or they meet at the line E, H. That is where the two planes are meeting. Is that okay? So if you go to the base, that is the plane E, F, G, H. We also divide it into two equal parts. We'll be having it, the line that is dividing the plane, it will be passing through the point Q. And if we go to N, we drop a perpendicular, it also, the two lines, they meet at L. So we continue drawing this, we'll be having, they are meeting at L. And the angle you're supposed to find is this angle. Do we know the length NQ? Or which length do we know? Which length do we know? We know NL. NL is just the translation of what? MG, which is a mass, LF. And that is what? 30 centimeters. Which one again do we know? So QL is the same as EF, which is the same as HG. And that is 40 centimeters. So from here now we decide which trigonometric ratio to use from this one. We have to get this angle, we have the opposite, this the adjacent. So we say that tan theta is equals to the opposite, which is 30, divided by the adjacent, which is 40. So you'll be having tan theta is equals to 0.75. So this 0 and this 0 cancels, you remain with 3/4, which is same as 0.75. Therefore, theta, it will be same as what? The tan inverse of 0.75, which is same as what? At 6.87 degrees. So that is the value of that angle that is dividing the two planes. Any question at that point? We go to part E. Someone to read that.
The angle between the lines EH and GF.
Now we find the angle between the lines EH and GL. You see where the lines are passing through. So where is our EH? Where is E? Where is E? EH is the base. That right? Then GL. Where is G? Where is G? G. Oh, the other L. Which L is this? Which one? This one. So now we could have used this as a different one, but we have already done that. GL and GL. I want you to see this clearly. So we have the angle between the line EH and the line GL. Which angle is that? I know you were taught skew lines. You see these two lines, they are not meeting anywhere. We have EH and GL. They do not meet anywhere. So if they do not, what do? You need to translate. Is that okay? So if you translate, which line can we translate? Which line can we translate? Which one? Which one? Huh? EH. We translate it so that it can be what? It can be FG. So they are now meeting. We have GL. Our EH is the same as what? FG. Is that right? So if you translate this one, translating it means you move it so that it will fit somewhere. So if we translate it, it will exactly fit here. So we'll be having a line that is moving like this. So we have this as our L, we have this is G, we are having this as F. And from L, if we drop a perpendicular, we meet it at what? At L. So the angle we are supposed to get, this same as our E, this same as our H. And the angle we are supposed to find is the angle between E, H, and G, L. Which angle is that? This angle. What is the value? Which dimension do we know? Which dimension do we know? Which dimension do we know? FG, which is same as EH, and that is 9 centimeters. Any other? Any other? Do we know FL?
Yes.
FL is same as GM, which is 30 centimeters. So we have, this is the angle we are looking for. So this becomes our opposite, and this is the adjacent. We use tan theta, which is same as, the opposite is 30, you divide by the adjacent, which is 9. You now have theta is equal to the tan inverse of 30 divided by 9. Where you want to get your theta is equal to what? Your theta becomes what? 73.330 degrees as the value of theta. And that is what was supposed to be done with that question. Is there any question?